Hello friends. The last video we saw the LeetCode problem of data structures and algorithms. We are given an input array. We want to see if it has unique occurrences. If the answer is yes, we return true. If the occurrences are similar for some of the elements, we return it as false. For example, the occurrences are frequencies. So 4 occurs 3 times in the input array in this given input. 6 occurs 2 times and 5 occurs once. So this is true because each element has unique occurrence, 3, 2, and 1. If any of the elements, for example, 5 had one more occurrence, it would be 2 and we would return it as false. So the LeetCode editorial solution says the approach as creating a map or a dictionary, storing the keys and the frequencies as values, and then creating a set, inputting the values from the dictionary into the set, passing it into the constructor, and then comparing the size of the set if it matches with the size of the dictionary. If the size matches, then it is true, it's a unique occurrence. If it doesn't, it is a non-unique occurrence. So I feel there is a very small or slight space optimization that is possible when we consider the current length of the input array, that is 1000. It shouldn't be a problem, but if we are talking about scaling and if the input array grows in size, then maintenance of a new data structure consuming more space might be a challenge in different scenarios, case by case basis. So how I would like to optimize slightly is creating a map and storing the keys and the frequencies or the occurrences as values and iterating over the map itself instead of creating a new set. For example, let us see the code. Public boolean is unique, has an integer array as an input. Create a map. We create a map of integers. Integer comma integer. Map. We'll do new hash map. For int key in array, the input array, we want to put map dot put the key, and we want to put the value as map dot, we want to get or default the key, and we want to increment it by 1. And then what we are going to do is we're going to open a for loop for int key in the map.keySet. This is a method in the map. We want to initialize a value, int val is equal to map dot get the value for the specific key, and then we're saying map dot put for the key, we're marking it as -1, and then we are checking if map dot contains value of the val. So after marking -1 for the key, after marking -1 as the value for the key, we are checking if there is any more occurrences in the dictionary. We're not creating any more sets. We're checking if there is any more occurrences for the value. If this is true, then we are going to return false. Else, we're going to return true at the end. So the idea is to iterate over the same map and marking the value as a -1 and checking if the map still contains the value. If the answer is yes, then it doesn't have unique occurrences, the array has duplicate occurrences. This is a very small optimization in space, but when we're talking about scaling, we don't want to maintain a new data structure. And even though the map, the space complexity, the time complexity of this is definitely order of n, because we are iterating over the number of elements of the input array, and the space complexity is also order of n because we are creating the map which has the input arrays and its values. And the map implementation, even though it doesn't, the space complexity doesn't grow any more than order of n. If you look at it is different for different implementation like Python or C or C++. In Java, it's the bucket size plus the number of values in the dictionary or the hash map. So this is still order of n, and even though the set in the previous LeetCode editorial solution, the space complexity is order of 1 because it stores unique elements. In this approach, we are completely eliminating the set. Thereby, when the question of scaling comes into picture, we are not maintaining an extra data structure, and we are iterating over the same map, which is order of n. Thank you for watching my video.